All right, so we were working on this earlier. This is going to be the same packet still. Should have had these blanks filled in, and you should have gone through and determined the valence electrons for each element, the number of electrons that are either lost or gained, and again, be sure to include that in there, gain or lose, and then the oxidation number that goes with it. Remember, if it's a -1 charge, it's because it has gained 1 electron, which has a negative charge, okay? And we're going to be working on this backside now. We'll start with number 1, which is sodium and chlorine. This is one we've already gone over. We talked about this earlier in class today. And there's a few things that go along with this. Number 1, let's read the directions. It says, for each of the following elements, draw Lewis dot diagram. So we'll do a Lewis dot for sodium and chlorine. And then we will arrange to show the transfer of electrons. Draw arrows to show the transfer of electrons. And then we'll write the chemical formula and name for the compound, which is here and here. So let's do it for sodium and chlorine, okay? Again, you can use your periodic table. You should have that handy. It'll help you. And if we look at sodium, has kind of a funny symbol, Na. And chlorine, Cl, okay? So that's number 11 and number 17. We said this first group is going to have 1 valence electron. So sodium, Na, will look like this. 1 valence electron. And chlorine, at number 17, is going to have 7 valence electrons, right? So remember, each period, that's the horizontal row, 1, 2, 3. This is a third period for chlorine. All you do is count how many groups over it is. 1, 2, there isn't anything here. 3, 4, 5, 6, 7. So it's in the 7th, and that means that it's going to have 7 valence electrons, okay? So that's how we can get a lot of information just from looking at our periodic table, okay? So here's my Lewis dot diagram for chlorine. Now, if we're trying to imagine what's going to happen here, for one, we have a metal and a nonmetal, so this is an ionic bond. We're dealing all with ionic bonds here, okay? One is going to be giving, one is going to be receiving. And if we go back to that concept earlier, the idea is it's trying to fill its outermost electron energy level, okay? And so this energy level for sodium can fill up to 8, but it only has 1 filled in there, okay? It only has 1 electron in its outermost layer. Chlorine can have up to 8, and it's missing 1. Okay, and so the easy transaction here is that sodium is going to give 1 electron over to chlorine, okay? And in doing so, sodium is going to go the next energy level down, and it's going to be filled in its outermost layer. And chlorine is going to get filled in its outermost layer. So both are satisfied through this transaction, okay? And that's good for this part. What I want here is formula. So in this case, we have 1 sodium and 1 chlorine. And so the formula for this compound, remember we have 2 different atoms, and they're 2 different elements, so it is a compound. We have Na and Cl. Always list the metal first, okay? And also we're going to say the name of this, sodium and chlorine. This was the example we used on the front side. We said we'll use the name of it, the metal, and the nonmetal is going to be, we change the ending to IDE. So this is sodium chloride. Okay? Let's try number 2. Okay? We'll get you on a good start here. So number 2, potassium and iodine. Again, we're going to do our Lewis dot diagram. We've got potassium, iodine. And I think we'll do one more example after this. Potassium and iodine looks like this. And if I look at them on the periodic table, I've got potassium all the way over. And at the top, we should have a +1. That came from this chart that we looked at earlier with our ionic charges for each group. And so, sorry, I'm talking to my daughter. And so with potassium, here, this is going to be 1 valence electron. Iodine, just the letter I. If we look over here, it's in group 17, just like chlorine was, okay? And it's way down there. Basically, it is missing 1. So it has 17. Okay, that's a lot to draw in there. There's 17, and it's missing 1, okay? So it's just missing that 1, and this is where we're going to have the transfer of electrons. Potassium is going to lose 1 electron. So it's losing, represented by a negative charged particle. So it's actually going to be a positive. So potassium is a +1 charge, and iodine is going to gain 1, so it's going to gain a negative, so it's going to be a -1 charge, okay? You don't have to write that on there. I'm just trying to help you conceptually. And so all it takes is this is a perfect transaction. Potassium and iodine, Ki. Potassium is a alkali metal, so we list it first. And then for the name, we're going to say potassium first, the metal, followed by the non-metal. Change that last syllable to IDE. So it's potassium iodide. Easy peasy. Let's skip to one that's going to be a little bit different. We'll go to number 5, okay? Same concept here, but you'll see when we get to determining the formula, it's going to be a little bit different. So calcium and chlorine. Let's go ahead and determine the Lewis dot diagrams. Calcium on here has a +2 charge, which means it has 2 valence electrons. It's in group 2, right? So 1, 2. Chlorine has, looking on here, it has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. And so the clear thing is, okay, chlorine's looking to fill its outermost shell, so it just needs 1. Getting 1 is a lot easier than giving away 7. And so calcium is happy to give it 1. But if you notice here, chlorine is satisfied, but calcium still has 1, which is not stable for it. Okay, so in our minds, we have to think, okay, what can we do to make calcium satisfied? And the answer, if you stop and think about it for a second, is we're going to have another chlorine, okay? And so keep in mind, in an environment where these two would chemically bond together, it wouldn't just be 1 calcium atom and 1 chlorine atom just randomly floating around. They'd have to be in an environment where there's a bunch of calcium and a bunch of chlorine, right? And so naturally, 2 chlorines would gravitate towards 1 calcium. And those chlorines, same deal, they have 7 valence electrons looking to fill 1. And this other one over here would come over to that spot. Now, in this case, chlorine is satisfied, right? So is this chlorine. Calcium also is satisfied because it's given away both of them, okay? And so you can kind of predict this. If we look at calcium and chlorine on here, calcium is over here, okay? Calcium has a +2 charge, and chlorine is over here with a -1. And in order to make that neutral, okay, with no charge, we have +2 and -1. We would have to have 2 -1s, right? And so that means we'd have to have 1 calcium at +2, and in order to get a -2 charge, we'd have to have 2 chlorines. So 1 Ca, calcium, 2 Cls, chlorine, and that's what our formula is going to be. CaCl2. Remember, this subscript 2 is telling us that there are 2 chlorine atoms, 1, 2. Calcium, you could technically put a 1 there, but we don't. It's extra work. But just by itself, Ca, this is implying that there's 1 calcium, okay? So that's our formula. The name, calcium, chlorine, is the nonmetal. We remove the last syllable and put in IDE. Calcium chloride, okay? And that's how we do it for these. You'll go through the rest on the front page, and you'll have the back page to do as well. And I will just throw out that there's going to be other compounds here where you have to look at the oxidation numbers to tell you how many atoms are going to be in one compound, okay? Just like we did in this last one with calcium chloride, our +2, -1 basically implies that in order to make this neutral, we're going to have 2 chlorines, right? Because then positive 2 and negative 2 cancels. And we end up with CaCl2, okay? All right, good luck.